Hey everyone, thanks for watching today's video where we're going to talk about the interior angles of a triangle. So the theorem with these is that the sum of the measures always have to add up to 180. And so this is a pretty basic formula. Let me get my right pen here. It's a basic formula, but it really helps us do things that we'll need throughout the entire course. So it's really important that you understand this and that you really just get this in your head and memorize it. You might already know it, but they have to add up to 180. So what this lets us do is if this is 65, and let's say this one is 45, I can now find this angle. And all I have to do is 180 equals, well, if all the angles have to add up to 180, I can just set that equal to all the angles added up. So 45 plus 65 plus x. 45 plus 65, that gives me 110. Plus x equals 180. Subtract 110 from both sides, and I can get that 70 equals x. So it just lets me figure out the degree measurements for all the sides of the triangle. If I'm just given 2, I can now find the third. And there's a lot of other things that we can figure out with this theorem, and we're going to go through examples that kind of show this. But just memorize this for the entire course. Interior angles of a triangle have to add up to 180 degrees. So let's take a look at this one. The angles in a triangle are in the ratio of 2 to 3 to 4. This is not an easy one, especially as the first one that you're doing with this formula here that says all the triangles, all the sides have to add up to 180, all the angle measurements. This is not an easy one at all. But, well, what can we figure out? So if the ratio has to be 2 to 3 to 4, I can just put in x there. So let's say one side will be 2x, one side will be 3x, one side will be 4x. This is okay because no matter what I multiply by that x value, if I divide and look at the ratios, they're still going to be proportional like I want them to be. But if I know that these are all the side lengths, now that I have a variable, I can now solve for x because I know all the angle measurements have to add up to 180. So if the angles are in that ratio and I know, well, all of them need to add up to 180, I now just solve this for x. So 2x plus 3x is 5x plus 4x is 9x. So 9x equals 180. Divide both sides by 9. I'll get x equals 20. But that's not my answer because the question says find the measurements of all three angles. Okay, well, if I know the ratio is 2 to 3 to 4, I know that one of them is 2 times x, one is 3 times x, and one is 4 times x. So now I just plug that in. So I'm just going to write angle 1, angle 2, and angle 3. And go in order. So angle 1 is 2 times x, that's going to be 40 degrees. Angle 2 is going to be 3 times x, that's going to be 3 times 20 is 60 degrees. And angle 3 is going to be 4 times x, which is 80 degrees. And so now quickly, we can see that the ratio is 2 to 3 to 4. If I were to divide those, I would get that ratio of 2 to 3 to 4. But let's make sure they all add up to 180. Well, I have 40 plus 60 equals 100 plus 80. That does equal 180. And that's my rule. So that works. So that was the correct answer. That's a hard one to do at first, but these are the three angle measurements. All right, let's take a look at the next one. So the angles of a triangle are represented by 3x minus 10, 4x plus 15, and 9x plus 15. What type of triangle is this? And we have the types that we're trying to look for, like acute, right, scalene, etc. So to find what type of triangle this is, we need to have the angle measurements, right? Or else we won't be able to tell, because scalene has to do with the angle measurements being equal or not, and acute and obtuse are obviously by the angle measurements as well. So let's add these up, set them equal to 180, and solve for x. So plus 4x plus 15, plus 9x plus 15. All of this needs to equal 180. And now we combine like terms. So 3x, 4x, 9x, that's going to be 7x plus 9x is 16x. And then we have minus 10 plus 15 plus 15, that's plus 20, equals 180. We want to get x by itself, so subtract 20 from both sides. We'll get 16x equals 160. Then divide both sides by 16. We get, okay, x is 10. Now, that's not the question, though, because that's good. That's a good start. But now it wants what type of triangle is this. So we have to do a lot more than this. So now we need to figure out the three angle measurements. So again, I'm going to say angle 1. That's my 3x plus minus 10 angle. And what does that become when I plug in 10? It's going to be 3 times 10 is 30 minus 10 is 20 degrees. So we got a short angle right there. We have angle 2, which is 4x plus 15. That's going to be 4 times 10 is 40 plus 15 is 55. degrees. Then our last one, angle 3, is 9x plus 15. And that's going to be 9 times 10 is 90 plus 15 is 105 degrees. And do those three add up to 180? Just looking at it quickly, they do, so we're good. Okay, now the actual question, what type of triangle is this? Acute, right, or scalene? Well, really, there's two classifications. The first one has to do with, like, is it an acute, a right, or a obtuse triangle? And I see instantly that it's obtuse, so we have an obtuse triangle here. Because one of the angles is greater than 90, it's an obtuse angle, so it becomes an obtuse triangle. Then now the last part is it scalene, isosceles, or equilateral, which means equal angles is what that means. So are the angles all the same? No, they're not all 60. Are the angles all acute? No. Are the angles all different? I mean, no. Well, yes, they are. So that means they are scalene. If two of the angle measurements were the same, we would say it was isosceles, but they are all different, so they're scalene. So it's an obtuse scalene triangle. That is our classification here. Because we have one obtuse angle and all the angle measurements are different, which makes it scalene. All right, so last question here. This is the more typical one that you'll get, and this is the important one for using this rule, solve for x. But notice that we have here, we're given that these symbols here. What this means is that they're congruent. These sides are congruent. That's what these dashes mean. And if the sides are congruent, that means the angles opposite them must be congruent. So the angle opposite this one, which is this side here, has to be congruent to the angle opposite this one, which is that angle here. So now I can write that in and say that, well, that has to be 2x minus 5. That's an important rule. So this is an isosceles triangle, and with isosceles triangles, the base angles have to be congruent as well as the sides. So now we have 5x plus 10. So now it's a simple problem, right? So plus, I'm just going to add up all three sides and then set that equal to 180. Add up all three angles, I should say. So plus 2, I'm just going to do 2 times 2x minus 5 instead of adding all three of them up, equals 180. And now I'm just going to distribute that 2. I'm going to get 5x plus 10 equals 4x minus 10, yeah. And then the plus and minus 10, oh, so this should be plus here. I accidentally wrote an equals. So 5x plus 10 plus 4x minus 10. Okay, so now the plus 10 minus 10 will go away, combine like terms. I get 9x equals 180. That means that x must be 20. And that's the question. All it wanted me to do was solve for x. So that's how I had to figure that out. So the key here was knowing that isosceles triangles have the same legs, so they have to be equivalent angles as well. And then we had to use this theorem that they add up to 180 to finally solve for x. So hopefully this makes sense. This is a really important rule here, that the interior angles of a triangle have to add up to 180 degrees. Make sure it's in your head because we'll be using it throughout the course. Thanks for watching, and let me know if you have any questions.